Okay, before the slide, this is a joint work between computer scientists and political scientists about, yes, how to evaluate the election process using CS tools in France. So the election we're focusing on, or the parliamentary elections, the setting is, the goal is to elect 577 members of parliaments. And for this, the territory is divided into 577 districts. And in each district, one member of parliament is elected through a two-round majority process. So a first round, there's a host of candidates. Everyone votes in one district. The two candidates who get most votes makes it to the second round. Then you vote again, and the one who gets most votes is elected. And in our work, we question how the division of the territory may impact or not the outcome of the election. So there's some legal constraint on how you are allowed to draw the boundaries. First, you have to respect some demographic balance, have roughly the same number of population in each district. And second, you have some geographical ones. The districts need to be connected, and they have to be local. They need to be contained in a geographical unit called département. Okay, so this is not in France, this is in the US, but does this look, okay, this doesn't look a reasonable district, and this may be called gerrymandering, which is the art of drawing districts to favor one's own party. And the name comes from a guy called Jerry who drew this salamander-like district. And in the US, this is a so common process that when people are not doing it enough, then a newspaper like Slate complain that Democrats are not doing it enough. And as a consequence, there's a vast literature on detecting gerrymandering in the US. In France, there's no such very weird-shaped district, and the reason is that the building blocks, the units that you're allowed to use for the districting are much bigger. I drew them here in one department, and so there's fewer of them, they're bigger, and so they constrain the shape, the possible shape of districts. So the rules, to summarize, there's some geographical ones, some demographic ones, and to compare France versus the US, the equivalent of department, so there's 100 departments in France, the equivalent is the states, or the states in the US, there are 50 of them. The building blocks, there's only 30 per department in France, about 160,000 in the US. So the difference is that in the US, you can draw the boundaries approximately however you want. It's a very continuous problem. In France, it's much more discrete. On the other hand, in France, the demographic constraint is a bit looser. You are allowed to have some gap in population between the different districts. Okay, so in France, the problem is much more combinatorial than in the US. And the question we ask is, does this impact the possibility to gerrymander? In the US, it's obviously possible to gerrymander because it has been done for the past century. In France, it's not clear, and it's not even clear whether it's possible or not. So to address this question of whether it's possible, we tried to study the diversity of possible legal maps in France. Okay, so our approach to study the diversity is to try to estimate the diversity of results, of outcomes of the elections. And ideally for this, we would like to look at all possible legal maps, compute the result of the elections on them, and study the distribution of the results for each party. And we would like to say that if, as in the left case, the distribution is uniform, then there's lots of margin. So, the x-axis is the result. So you can win 2 seats or win 1 seat. And the y-axis is the frequency of this result. Okay. So the first step of this approach is to simulate the election. For this, we use data generated previously. In France, the problem is so discrete that you can actually generate all maps, all possible legal maps. And we have public access to voting data at each election. There's one issue with this, is that we know what people voted in reality, but we don't have access to their preferences in the second round. If we change the districts, we change the candidates, we change the outcome of the first round, and then we don't know what would be the outcome of this virtual second round. So we only consider the votes in the first round and declare winner any party which would qualify to the second. And we argue that this is still a valid measure of diversity of the outcomes. And we used the result from election 2 years ago in France, where there was 4 alliances, a left one, a right one, a conservative right one, and a far-right party. So to study the distribution of results for our second step, we propose several metrics. First, at a national level, to estimate whether it's possible globally to gerrymander, to change the outcome of the election, and by what margin. And then we zoom in at a departmental level to see where geographically the variation comes from. Okay, so at a national level, the outcome looks like Gaussians. So again, x-axis is how many times a party won, y is the frequency. It looks a lot like a Gaussian, which is not surprising because it's a sum of results in 100 departments. But the tails are very heavy. For instance, in the first party, the NUPES, the minimum is very far away from the average and very far away from the maximum. And in practice, the outcome of the elections were in the tails. So disfavorable for the first 2 parties and favorable for the last 2. So this shows that we shouldn't consider the outcome of the election as a Gaussian, and we should instead zoom in to department, where the results are not anymore Gaussians, because there's not this sum procedure that smooths out everything. And so in this case, we introduced a definition to study the diversity based on the shape of those histograms. We consider the mode of the histogram in a given couple party and department. For instance, the left picture, the mode is 5. When we looked at the value of the mode, so the frequency of the mode, we said the department is hardly gerrymanderable. This value is more than 0.9. And our argument is that if 90% of the map yield the same result, and the true outcome of the election is not this result, then the person who drew the map should have a very strong argument why this is the result, and why it didn't fall into the 90% case. Then we have definition of possibly gerrymanderable and gerrymanderable with values that are arbitrary, but changing them doesn't change this table when we count the categories. So perhaps surprisingly, half of the cases are hardly gerrymanderable, so there's very few diversity in half of the cases. But on the other hand, there's 30 cases where there's lots of flexibility to choose the boundaries to favor your own party, which is a bit surprising, this balance to me. We can discuss that afterwards. So to conclude, okay, redistricting in France is different than in the US because it's possible to enumerate all solutions, and we propose to examine the diversity of maps to detect the possibility of gerrymandering, and this question was surprisingly new. There's a bit more in the paper. We evaluate the current map, whether it's an outlier, whether it's been the outcome of a gerrymandering process. It seems an outlier. This is a first step, a very basic step to audit redistricting in France. There's limits of our assumptions. We simulate virtual elections, which is not clear what it means. The second round may have a big impact. We have a few open questions. I'm from CS. I think there are very cute questions about how to sample a compact map efficiently. And we have some political science questions to explain more our results based on precise case studies. Thank you.